Today we're going to talk about calorimetry, and anytime you have a word that has the ending of metry or meter, it means to measure something. And then calor is like calorie, it means heat. So calorimetry is the measurement of heat. And you're going to measure how the heat is transferred, because remember, heat is a transfer of energy. So you can trap the energy into one system and figure out how the heat is flowing. So calorimetry is the precise measurement of the heat flow out of a system for chemical and physical processes. So the idea is if you have a reaction, like let's say we have an exothermic reaction, you can't actually measure the temperature change for the reaction particles themselves, and you also don't know the specific heat for a reaction. So in order to calculate the heat, the Q value, what you do is you put it into water, because when it's aqueous it flows better, and the water that's surrounding the reaction is going to absorb the energy. So you've got the reaction giving off energy, and the water surrounding it absorbing the energy. And you can measure the amount of water, you know the specific heat of water, and you can see how the water changes temperature. So the whole idea for this lesson is that the negative heat of the reaction is equal to the positive heat absorbed by the water. So what you can do is calculate the Q of the water, and then that value is the same as the heat given off by the reaction. You just make it negative to show that it's exothermic. So you can plug in the MCAT values, where you have everything about the reaction on one side and the water on the other side. And this is assuming that you're trapping all the energy in. So we use a calorimeter, which looks kind of like this. It's like a container that tries to trap in as much energy as possible. Because you have to assume that no energy is lost to the environment. So let's do a couple of example problems. The first one says how much heat is released by the reaction if 10 grams of water is heated from 20 degrees to 60 degrees. So the problem is, like I said, we don't know the specific heat of the reaction, we don't know the temperature of the reaction or any of that stuff. But what we can do is calculate the Q for water. So let's go ahead and set up the Q for water. We've got the mass is 10 grams. It's between 0 and 100, so we know it's liquid water, so you can use the specific heat for liquid water. And the change in temperature is from 60, or from 20 to 60. So you want to do 60 minus 20, final minus initial. And when you calculate that, you get 1672 joules. That's the amount of energy that is absorbed by the water. But that's not what the question asked for. The question said how much heat was released by the reaction. So the idea is that the amounts of energy are the same. They're both 1672 joules, but to show that it's released by the reaction, you're going to put a negative in front of it. And that negative just means that it's being given off. It doesn't mean less than 0. Let's look at number 2. It says, what is the mass of the water? So we haven't really calculated any of the other variables in this equation, but you can. So in this case, we're going to calculate the M value in the MCAT equation. And the problem with this is you have to be really careful with the wording. It says that a release of 650 joules of heat causes the water to increase in temperature by 15 degrees Celsius. So we're focusing on the water in this case. This word release makes it tempting to put a negative sign in front of the 650, but the 650 joules that's being released is from a reaction. So in this case, it's an exothermic reaction. The water is absorbing that amount of heat. So even though you see the word release, that word is talking about the reaction. We're focusing on the water for this question. So we're going to leave it as a positive 650 joules. And we're going to use liquid water, so 4.18 is your specific heat. And then also notice that it only gave you one temperature, and a lot of people get flustered by this and think that they're missing another temperature. But notice that it says it's increasing by 15 degrees Celsius. So this is the delta T. This is the change in temperature. They already subtracted them for you. So water absorbed 650 joules of heat from the reaction. So we can plug in 650 joules for the Q value. We're solving for M. We know the specific heat of water, and we know that the change in temperature was 15 degrees. So then you just have to do the algebra to rearrange the equation and solve for mass. The next one says, what is the final temperature? So this time we're looking for T final. We've got 15 grams of water, we've got an initial temperature, and we know that it's losing 300 joules of heat. So the water itself is now losing the heat, which means that this amount of joules needs to be negative when you plug it into your equation. So we've got negative 300 joules because losing heat is negative. So notice that our Q value over here is negative. We've got the mass of the water is 15 grams. Specific heat is 4.18. And notice that we're solving for the final temperature. So we're given 20 degrees as our initial, we're solving for the final temperature. And then it's just a matter of if you can do the algebra. So you want to take negative 300, divide it by 15, divide it by 4.18, and then finally add the 20 degrees at the very end. And check and make sure your answer makes sense. If the water is losing heat, that means it's going to be colder to end with. So if you get a temperature higher than 20 degrees Celsius, you know you calculated something wrong. And if you do it correctly, you should get 15.2 degrees Celsius. Alright, last problem together. It says determine the substance. So on the final exam, there's a good chance that you'll be asked to determine what something is. And there's two ways you can do it. One way is if you use density. We did that way back at the beginning of the semester. So if you use mass over volume, you can figure out the density and then match it up on your reference tables to see which substance it is. Another way you can do it is using specific heat. So in this case, we're given the mass, we're given the change in temperature, and it's absorbing this much energy, so that's our Q value. So in this case, we're going to solve for C, because C is the specific heat. So our Q value is 368.3. We know the mass is 20 grams. Specific heat is what we're looking for. And then don't forget to do final minus initial. And when you calculate C, you should get 1.02 joules per gram degree Celsius. And if you look at the first page of your reference tables in the bottom left corner, there's a chart. And if you find on that chart the column that says specific heat, magnesium should have exactly 1.02 as its specific heat. So we know that this is magnesium. And the last thing for today is we just need to talk about enthalpy a little bit more. The symbol for enthalpy is delta H. And we talked about it when we did those graphs with the hills. This is the difference in energy between the products and the reactants. Difference between the products and the reactants. So the equation is kind of like any delta equation. You always do final minus initial. So the delta H for the reaction is the products minus the reactants. So for exothermic reactions, the delta H is going to be negative. Anytime you have a negative, it's exothermic. And that's because exothermic reactions lose energy, so you end up with a smaller amount of energy than you started with. So if you plug it into that equation, if you have a small number for the products and a big number for the reactants, it's going to give you a negative value. So it's negative because the products have less energy than the reactants. It's the opposite for endothermic. So for endothermic, you're gaining energy, which means you end up with a higher energy than you started with. So if you plug it in, you have a big number for products minus a little number for reactants is going to give you a positive value. So what you need to know is what enthalpy is. You need to know that it's delta H, that if it's positive it's endothermic, and negative is exothermic. And the other day we talked about the fact that nature favors exothermic reactions, and that's because they have a lower activation energy. So if it has a lower activation energy, it's going to be able to react a whole lot easier, so nature is going to choose the easier path. And sometimes you'll see it written this way, where you have a reaction, and then you have the delta H written off to the side. If you look at the sign that's on that number, it'll tell you whether it's endothermic or exothermic. So in this case, I know that this reaction is exothermic because of that negative amount for the kilojoules. Again, that negative doesn't mean less than 0, it just means this much heat is being released. And that's all for today. I want you to try some on worksheet 6 to practice the calorimetry, but be really careful with your units. Anytime you're using specific heat, your mass needs to be in grams, so watch out if I give you kilograms. And your energy needs to be in joules, so watch out if I gave you kilojoules. Make sure you convert those first. And make sure you check your answers as you go. And that is it for today.